Hi, boys and girls. So today you are starting a new lesson, all right? We're moving on to lesson 20, and luckily it's pretty similar to lesson 19. So we're continuing with adding and subtracting fractions as our topic. And our target or our goal for this lesson is for us to be able to decompose fractions and solve word problems involving adding and subtracting fractions, okay? So on your assignment today, you're supposed to read the family letter, but instead of reading that, I kind of made one for you guys, all right? So I just want you to first follow along with me here. The family letter is on page 411, but right now you can just follow along with me here, okay? So I want to remind you that when you add or subtract fractions with like denominators, when you say like denominators, it means the same. You can simply add or subtract the numerators and keep the denominators, right? So when the denominators are the same, you can just go ahead and add or subtract the numerators, which are on the top, and you keep the denominator. Now I'm going to show you some examples. One is involving addition and one is involving subtraction, okay? So the first example says, Miss Chase shared her 12 cookies. She gives Ayla 3, Shayla 4, and Austin 5. What total fraction of cookies did Miss Chase give away? Okay, so first of all, I need to think about what is this word problem asking me to solve? It's asking for the total fraction of cookies. So if I'm thinking total, I'm probably going to be adding, not subtracting, right? Because I know Ayla had 3, Shayla had 4, Austin had 5, and I need to find the total. So I'm going to add those. So I'm going to show you some different ways that you're going to be solving these types of problems. So one way is to do a picture. So in my picture, I showed 12 cookies. I know that's what I'm starting with. I have 12 equal parts. And now I'm going to go in and label who gets those cookies, okay? So how I like to do it is use a letter to show instead of shade, okay? Because that just reminds me who gets what. So I'm going to start with Ayla, and I'm going to use Ayla's initials, A-T, and I'm going to do A-T in 3 of these cookies because that's what Ayla had. A-T, 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 okay? Then, I'll move you guys over a little bit. Whoa. Dropped my book on the floor. Okay, so we have Ayla. Now how many does Shayla have? Shayla has 4 cookies. So I'm going to go in and label Shayla with a C on 4 of the cookies. Okay. Now, how many cookies does Austin have? Austin was really hungry, guys. He had 5 cookies. So I'm just going to do an A for Austin on 5 of the cookies. 1, 2, 3, 4, 5. Okay. So I can see here that I have 12 out of the 12 cookies given away, right? So I'm going to show you that in a regular equation. So we're starting off with Ayla. She had 3 12s, right? When I do a fraction bar, I can also say out of. So I could say 3 out of 12, okay? Plus, what did Shayla have? Shayla had 4 out of 12. Plus, what did Austin have? He had 5 out of 12, okay? And then we can add those. The reason it's very easy to add these is because they have like denominators. They all have the denominator 12, right? So even though there's 3 of them, I can still just add the numerators and then I'm going to keep the denominator. So 3 plus 4 is 7, plus 5, 7, 8, 9, 10, 11, 12. Okay? So my answer is actually going to be 12 out of 12. Okay? I know when a fraction has the same numerator and same denominator, that means it's the same thing as 1, just so we can be aware. So this equals 1, which means I gave away the whole thing, my 1 whole of all my cookies to my students. Aren't I nice? So now I'm going to show you one more way to do it on a number line because you're also going to see that. So we're going to start with Ayla here. She has 3/12, right? So my number line is counting up by 12ths, right? And I'm going to start at 0 and I'm going to hop 3 times for Ayla. 1, 2, 3, okay? Now I need to hop 4 more times for Shayla. 1, 2, 3, 4. Now I need to hop 5 more times for Austin. 1, 2, 3, 4, 5. Okay, so on my number line, I also get the answer 12/12, right? When we did it in an equation, we got 12/12, and when we showed a picture, we got 12/12, okay? Let's take a look at the next problem. So it says, Reese and Jason collected basketballs after recess. They found 7/8 of the balls. Must have been one pesky ball that was getting away from them. Reese put away 3/8 and Jason put away the rest. What fraction of the balls did Jason put away? Okay, so for my picture, I know my number of equal parts is 8. I drew 8 balls. You could have also drawn a chart with 8 equal sections. It doesn't matter, okay? And so how many of these balls does Reese initially gather? Do both boys gather? Reese and Jason collected them together. So they collected 7/8 of all the balls, right? So I'm going to go in and shade just quickly. 1, 2, 3, 4, 5, 6, 7. Now, Reese put away 3/8 of those balls and Jason put away the rest. What fraction of the balls did Jason put away? So first of all, I'm thinking, what do I need to do to solve this problem? Am I adding or subtracting? I want to figure out how much is in the rest. And when I hear those terms, it usually means I'm subtracting, okay? So I need to take away 3/8. So I'm just going to X out 3 of the balls that I shaded. Bye-bye, bye-bye, bye-bye. And then my answer would be, what is remaining? How many of these balls are remaining? 1, 2, 3, 4. Out of how many? 4 out of 8. Okay? Let's do that equation out with the fractions. So the boys are starting with 7/8 of the basketballs. Reese puts away 3/8. And we need to see what is left that Jason put away. So since these have like denominators, we're able to subtract across the numerators. So 7 minus 3. So start at 7 and count back, or you could start at 3 and count up. So if I start at 3, 3, 4, 5, 6, 7. So that's going to give me 4/8. I keep my denominator. Okay? Now, one last way I'm going to show you is on the number line. So we are going to figure out what we're starting at on the number line. So we need to start off with our big fraction here. So we have to hop all the way up to 7/8. Okay, so we're going to hop up 1, 2, 3, 4, 5, 6, 7. Okay, we've made it up to 7/8. Now we need to take away 3/8. So I have to start at my 7/8 and I need to hop back. So this is how I'm going to show it hop back. I'm going to just draw it a little bit over it. 1, 2, 3. What does that bring me to? 4/8. Just like I found here, and just like I found here, okay? The last thing I want to go over on this is called decomposing fractions, okay? So when you decompose fractions, it means you're breaking them down, okay? You're breaking them apart. So for example, this should be 4. So write 4 ways to decompose 8/9. So all you have to do is say what fractions can add up to equal 8/9. So for example, 8/9 could equal 4/9 plus 4/9 because sorry, someone calling me, because because 4 plus 4 is 8, right? And the 9 stays the same. 8/9 could also equal 6/9 plus 2/9 because 6 plus 2 is 8 and the 9 stays the same. 8/9 could also equal 2/9 plus 2/9 plus 2/9 plus 2/9 because 2 plus 2 plus 2 plus 2 is 8, right? 2, 4, 6, 8. And you keep the 9. Also, lastly, to show 8/9, you could add 1/9 8 times, right? 1, 2, 3, 4, 5, 6, 7, 8. And then you keep your denominator the same, okay? So those are the types of things we're going to be doing in lesson 20. I'm going to have you open up now to page 413 of your book. Since I took a little while to review that, and I hope that you listened so carefully, I'm going to skip around some problems, okay? So some of them we're not going to bother with. Okay, if you need a minute to open up to page 413, please do that. Otherwise, I'm going to start with the problem. So it says, Lynn, Paco, and Todd share a pack of 12 cards. Lynn gets 4 cards, Paco gets 3 cards, and Todd gets the rest of the cards. What fraction does Todd get? Okay, for this one, I'm going to show you how to draw a picture. So first of all, they already kind of drew one for us, but we need to draw like a math picture. So we need to think of how many equal parts do we have to show? There's going to be 12 equal parts because there's 12 in total, right? So I'm going to make a chart on my thing. I'm going to make a rectangle. And when I want to break something into 12, I like to first break it in half the long way. Then I break it in half this way. And I have to break these into 3 columns each. Okay? See how I have 12 there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So I have 12 equal parts. You could also put 12 circles or 12 of anything, okay? Doesn't matter. Now, I need to see. We're figuring out Lynn gets 4 cards, Paco gets 3 cards, and Todd gets the rest. So let's label what Lynn has by putting an L in 4 of the cards. So we have 1, 2, 3, 4 is Lynn. Now Paco has 3 of those cards, so 3 are going to have a P for Paco. Okay, and Todd has the rest. So that means any that are still left will belong to Todd. So 1, 2, 3, 4, 5 are Todd's. So since Todd has what's left, Todd is going to have 5 out of what is the total equal parts? 12. Okay? 5 out of 12. Pause me if you need to. Otherwise, I'm going to jump on to 414. Okay. Number 2 says, in the problem on the previous page, the whole is the pack of cards, okay? So here, the whole was all of the cards. Since there are 12 cards in the pack, each card represents 1/12 of the whole. Look at the whole shown here. The whole is the pizza. It is a single object. So the whole would be the entire pizza, right? The whole thing. And this is breaking it down for us. It says, how many equal parts are shown in the pizza? Well, we're going to count the equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 equal parts. What fraction can you use to describe each piece of the pizza? So if we're only talking about one piece, what fraction could we use to describe that? Well, that's going to be 1 out of our 8 total pieces. So 1/8. Okay? Then it says, what fraction could I use to describe the whole? Okay, so how many parts are in this whole in total? I hope you're saying 8. So there's 8 parts in the whole out of how many total parts? 8. So instead of saying 1, we could say 8/8, right? And we know that's the same thing as 1 because any fraction that has the same numerator and same denominator is equal to 1, okay? What fraction can you use to describe the 3 pieces being taken away? So what fraction describes these 3 pieces? 3 out of 8, okay? The reflection part says, how does knowing about equal parts help you add and subtract fractions? So I'm not gonna make you write this one, but knowing about equal parts helps us to add and subtract because when you have the same amount of equal parts, so the same denominator, you can simply add or subtract the numerators, right? All right, I'm going to skip page 415 because we really reviewed a lot when I went over my poster. So we're skipping that. And then we're going to go to page 416. Okay. So we're looking at problem 3 on 416. So the problem says, Maria, John, and Kara share a set of 10 animal stickers. So right away, boys and girls, we know that in this whole, there's 10 equal parts. Maria gets 2 stickers. John gets 4 stickers. And Kara gets the rest of the stickers. What fraction of the stickers does Kara get? Okay, so let's start by drawing a picture. So how many equal parts do we need to start with? 10. If you want, instead of redrawing it, we could just use these that they already have as our equal parts, okay? So let's label them. We know Marla gets 2. So 2 of these we can put an M over for Marla. 2 for Marla. And we know John gets 4. So let's put a J for John over 4 of them. 1, 2, 3, 4. Okay. And then Kara gets the rest. So let's put a K for Kara on the rest. 1, 2, 3, 4. Okay, so how many stickers does Kara get? 4 out of how many is 10. Okay, so those, I know it says check your work on the bottom, but I'm going to let you off the hook here because you've been listening for a little while now. So that's all I'm going to have you do in your workbook today. You're going to look at the checklist to see what else you need to do for math today. Now, boys and girls, I'm really confident that you guys can learn this topic. It's not anything too crazy. So in distance learning, it's your job to really be listening to my videos on the computer. And if you need to hear them again, you go in and you watch them again, okay? You do what you need to do. But I was a little discouraged last week when some people told me that they didn't know how to do any of the math, because that makes me wonder if you're really watching these videos, because I really tell you a lot, okay? These posters are super helpful in doing the book pages together. So if you're doing the work and you're listening to me, you guys are all capable of learning this topic. I know it. Okay, so try hard this week and try and really learn this. So when you take the comprehension check eventually, you're going to ace it. Get 100. All right? Bye, boys and girls.